Hello everyone. In this talk, we will introduce a paper called A Sensitivity Analysis of Convolutional Neural Networks for Sentence Classification, which has performed a detailed analysis on the effect of model components and hyperparameters for convolutional neural networks. Convolutional neural networks has recently achieved good performance on the task of sentence classification. However, the convolutional neural network requires researchers to specify an exact model architecture and hyperparameters. It's unknown how sensitive of the model performance is to change these configurations for the task of sentence classification. Therefore, this paper conducts a sensitivity analysis for one-layer convolutional neural networks to explore the effect of architecture components on model performance. This paper used 9 sentence classification datasets totally. So, what is sentence classification? The input of the sentence classification task is a sentence, and the output is the class of this sentence. So here are two examples in the movie review dataset. As we can see, the sentence in gray denotes a positive review, and the sentence in red denotes a negative review. Here is a toy example of the model architecture. In the middle left, we have a sentence as input. Each word in the sentence denotes as a vector, so the whole sentence can be considered as a matrix. Here we assume the length of the vector is 5. Because there are 7 words in the sentence, so we have a 7 by 5 matrix as input. In this example, we use 6 filters as shown in the red, green, and yellow. The region sizes of the yellow filters are 2, the region sizes of the green filters are 3, and the region sizes of the red filters are 4. Therefore, if we use step 1 convolution without padding, the result of the yellow convolution will be 2 6-dimensional vectors. And the result of the green convolution will be 2 5-dimensional vector, and the result of the red convolution will be 2 4-dimensional vector. And then the model conducts one max pooling for each output of a filter. The final features will be 6-dimensional vector. Then we can use these vectors to do softmax classification. The first experiment in this paper is to investigate the effects of input word vector. The author utilized word-to-vec, glow, and their combination. In Table 2, each cell reports the mean, minimal value, and the maximal value of the summary performance measure calculated over multiple rounds of 10-fold cross-validation. The authors will use this format for all tables in this paper. As shown in Table 2, the relative performance achieved using globals versus the word-to-vec depends on the dataset. And simply concatenating these representations are not necessarily helpful. The second experiment in this paper is to investigate the effect of filter region size. The author explored 9 values for the filter region size, from 1 to 30. From the results, one can see that each dataset has its own optimal filter region size. This suggests performing a coarse-grained search over a region size is necessary. For the datasets comprising short sentences, a reasonable range will be 1 to 10. And for the datasets comprising longer sentences, the optimal region size may be larger. The authors also explored the impact of combining different filter region sizes. They found that combining several filters with region size close to the optimal single region size can improve performance. But adding region size far from the optimal range may hurt performance. The next experiment in this paper is to investigate the impact of the number of filter maps. We also tried 8 values for the number of feature maps. As shown in the figure, the best number of feature maps for each filter region size depends on the dataset. However, the results show that a better choice for the number of feature maps is between 100 to 600. The next experiment in this paper is to investigate the impact of activation function. We consider several different activation functions in the convolution layer, include the ReLU, tangent, softmax, and identity function. As shown in the table, the tangent function outperformed others in 4 out of 9 datasets. The ReLU function performed better in 2 datasets. One interesting result is that not applying any activity function sometimes helps. This indicates that on some datasets, a linear transformation is enough. Then the author also explored the impact of a polling strategy. They compared one max polling with local max polling, k-max polling, and average polling. They found that one max polling consistently outperformed other polling strategies. To explore the impact of regularization, the author tested 10 dropout configurations from 0 to zero point 0.9. From figure 4, we can see that the non-zero dropout rate can help some points from point 1 to point 5, which depends on the dataset. The author then also explored dropout rate impact by increasing the number of feature maps. They increased the number of feature maps for each filter size from 100 to 500. We can see that the impact of dropout rate is almost the same as when the number of feature maps is 100, and it doesn't help much. The authors also experimented with applying dropout only to the convolution layer, but the results show that the dropout on the convolution layer helped little, and large dropout rate dramatically hurt performance. The author also considered the impact of the L2 normalization imposed on the weight vector that parameterize the softmax function. Figure 5 shows that imposing a L2 normalization constraint generally does not improve performance much and even lead to adverse effects. So in this paper, the authors gave a following conclusion to guide researchers to use convolutional neural networks for sentence classification. First of all, the choice of input work vector has an impact on performance. And second, the filter region size can have a large effect on the performance. And third, the one-max polling strategy uniformly outperform other polling strategies. Fourth, the ReLU and the tangent function has a better activation function. And fifth, we can alter the number of filter maps for each filter region from 100 to 600. And last, it's better to use a small drop-off rate from 0.1 to 0.5. So that's it. Thank you.